widescreen.
Questions? Homework? Thank you.
Why did I die?
Say again? Okay, all right. That gets too bleak. So last time we did 4-7. So we're done with chapter 4. I just want to do maybe a quick example of what that was before we get into chapter 5. I'm thinking about having a quiz. Let me say it like this. Either Monday or Tuesday? What do you want? Tuesday? Friday?
Tuesday.
So that makes it so you can't just say no quiz. So the only options are those 2 days.
Damn it.
So we're going to have a quiz Tuesday. It's going to be 4.5 through 5.1. Yeah. Dude. I like it. I would. All right. So here's what's going on in section 4.7. We would have something like, let's see, what you got? 3x minus 2y less than or equal to, you can do it, dude, 8, sure. So the difference here is I've got an inequality, not just an equal. So if it was equals, I know how to graph this. It's just a line, right? And something I wanted to do yesterday, before we get fully into this, how do I, if I said, find the solution and graph it for this, like way back when, how would I find the solution for this?
Subtract 1?
Yeah. Solve for the point and then plot the point, right? Ooh, that's amazing. You guys semi with me? Right. And now watch. If I said, oh shit, I meant to graph this, you would still want to get the point. You would still want to solve for the point, and then you tell which side of the point to graph the shape. You guys with me? That is like saying something we've done before in a weirder way, but it's getting us closer to why that makes sense. So if this was equals, I would of course solve for y. I can get my slope, my y-intercept, and plot the line. I added the inequality. Now on top of graphing the line, I got to figure out which side to shade. Exactly the same as what I do here. So there really is no difference. There's just an extra dimension, which sounds freaky as shit. It's just adding the y-axis, though. That's all, right? So plot a point, you put an inequality, now I got a shape. Plot a line, you put an inequality, now I got to figure out what side of the line to shape. Exactly the same. So how do I figure out the parts of this line so I can graph it? What do I do? To find what parts of the line do I need to graph it? Slope, y-intercept, I love it. So how do I get that? Yeah, subtract 3x, I like it. And I am going to shove that dude, all right, just to get it in the right format. Divided by -2. So what's that mean?
So that ends up just being y equals -3 over, oh, equals.
What happens to this? Got to flip it because they're divided by negative, right? And of course here this becomes positive 3/2 x -4. Okay, so now you can see the slope, the y-intercept. You can plot the line. All the inequality does is it says, oh yeah, you got to include all the points on one side or the other, because they would be all the points where it's bigger than that line. Okay, maybe. So take a minute, plot the line, and then maybe shade if you can, if you remember how we did that yesterday. classroom, some assembly required. Which green is going to work? That's not too bad. See how you. Oh, not so good. So my y-intercept.
3 over 2.
I'm sorry.
0, -4. And then from there, I'm going to go up 3. 1, 2, 3. Over 2. You were just ahead of me. What kind of line am I going to make? Solid. A student in my class a while back said, if you see a line, if you see a solid line, you make a solid line. You see that? If that wasn't there, you would make a dotted line or dashed line. I like it. So I'm going to make a solid line because it's allowed to equal that line. Hey. And then I gave you the shortcut, which is, where are the y's bigger than this line? So there's a y right there, right? Where are the y's bigger? Up or down? Up, yeah. So it's greater than, so I shade up. The other way to do this is, if you pick a point like 0, 0, does it work? 0 minus 0, is that less than or equal to 8? 0 less than or equal to 8? Is 0 less than 8? Yes. So therefore I'm going to shade in the direction of that point, because that must be where all the points work. Because either they all work or they all don't work, right? All right, maybe. Okay, that was a quick review of what we did yesterday. So what are we going to get into today? Oh, from yesterday? Yeah. Okay. So that's up on the internets, on the YouTubes. By the way, I don't know, how much have you guys heard about the coronavirus thing and Grossmont's response?
It's spreading like crazy.
A little bit.
Someone did a prank.
Somebody did a prank. Yeah, that's right. Sort of like calling it a bomb threat to kind of get out of classes, and it didn't work, thankfully. So there is a plan. We're trying to develop a plan about which courses could be moved online. Personally, if I had to make it so that my courses were taught online and finals were done online and all that shit, I would say no, I'm not doing that shit. I can't trust everybody. I'm not going to give a grade to a student I can't see them working on their final. I'm sorry. Does that make sense? Yeah. But there might be other alternatives. So the school is working on some stuff, because it looks like some local schools like San Diego State, USD maybe? UCSD or USD? I can't remember. And Southwestern is planning on, yeah. I personally think that's a little bit jumping the gun, but
UCLA just closed yesterday.
exactly. There's other colleges across the state that are doing things.
So what would be your alternative? Are you going to just freeze the class?
So there's a lot of things involved in this. It's what are we able to do legally?
Suspend the class and go into summer.
That one option would be some kind of withdraw everybody and reimburse, but that needs to be discussed.
No.
What?
I need this class to graduate high school.
Well, again, it could be on a case-by-case basis for some people. I'm not saying that anything coming in my mouth is going to be exactly what we do, because it's all in flux, and some of the resolutions might be dependent on people's situations. But the bottom line is, you ain't going to get a grade from me if you're taking some online test. I'm sorry. It just ain't going to happen. Not with me. I don't care what the hell somebody tells me. You better do this, Jeff, well then fire me. I'm sorry. It's not that I don't trust any one of you. I just can't trust everybody, so therefore it can't be done. So in general, just keep an eye on your email. There's actually a link on the Grossmont website that goes to specific information. It's nice to know the general information, but you also have somewhere to go for Grossmont specific information about what we think is going to happen. But there's a lot of things in discussion because it's really not certain what we're able to do in certain situations. So, okay. So anytime you want to ask me, I can tell you what I know, which very often is not that much because not much has been decided yet. All right, so we'll see what happens. Okay. So somehow letting go of all that. We've passed that for right now. Here's what we're getting into. So here's, maybe you'll pick up really quick why I didn't want to put anything between what we just did and what we're doing. It's going to be really dependent on our ability to graph, especially to begin with. So what's kind of wrong with me asking you, what are the answers to this? If I just said solve this, what's kind of wrong with that?
Solve for what?
Yeah.
What?
Why?
Solve it. Does this have answers?
No. Oh, yes. Yes. Yes.
Does this have answers?
Yes.
All right, so solve it.
Negative x plus 6.
No, that's just rearranging it. I want you to solve it. So you guys are picking up. There's obviously there's an inherent problem what I'm asking, correct?
Yeah.
And in fact, you know exactly what it is. How many answers are there? Infinite number of answers. So no, right? So what we do as a compromise is we graph. The quickest way to answer what are the answers is to give a graph. Because that when I draw that line, I fill in all the infinite points in there as I create the lines. Is everybody cool with that? We've talked about that already. So in general, the problem with this is I can't get a specific solution. There's an infinite number of solutions. And let's really think about why that makes sense. How many answers are there possible to a problem like this? And I say solve this. Why is that okay for me to ask that? Because there's going to be just one answer. Most of the time. There's just weird things where it's all real numbers or whatever. But most of the time, this is going to have one answer. So why does it make sense? How many things do I not know in this equation? How many? Yeah, that's it. There's one thing I don't know. And how much information have I been given? One piece of information. Now, what stay with me. So there's one variable that I don't know. And I've been given one piece of information that kind of matches. I should be able to solve it. Yes?
So for the first one, I could, to add information, the one you wrote down to add information, I could say, assuming x is 1 and y is 2, that would give the information.
Well, if you assume x is 1 and y is 2, that doesn't work.
Yeah.
But I think I see where you're going. But that's too specific. They're not going to just tell you what one answer is.
Or is
Don't
like
get
one
too
answer,
hopeful.
like,
So here's how it's going to work. How many things do I not know here? 2. How much information have we been given? 1. We have one relationship. Therefore, what's it make sense? I need how much more information to solve this? One more piece of information. So if I said I'm twice as old as you are, do you know how old either of us are? No, because there's 2 things you don't know, and I only gave you one relationship between those 2 things, right? So let me see. If I tell you 2 numbers add to be 6, there's an infinite number of those. Right? The ones you think of, 1, 5, 2, 4, but what about 5.5 and 0.5? And all that kind of shit. You with me? So what if I also tell you, so hey, do this. Give me some answers. So I just gave us some answers. 1 and 5, 2 and 4. What else? 3 and 3. 0 and 6. Give me 2 more.
5 and...
Yeah, 0.5 and 5.5. What about -2 and what? You can do it. You can do it. 8.
Yeah.
Right? -2 plus 8 is 6. And of course, like we said earlier, this would take an infinite amount of time to finish. So what if I also told you, not just this one piece of information, what if I also told you that their difference is -2? Do we already have the answer up there? Can you guys see the answer? What's the difference here? 1 minus 5 is? 1 minus 5 is -4. What's 2 minus 4? 2 minus 4. 2 minus 4.
Oh, 2 minus -2.
-2. So see how this one point does meet both of these. Do you see that? When I have two things I don't know, I must be given two separate pieces of information. So here's one piece. They add to be 6, and I'm like, well, that could be anything. And then they, oh yeah, but they subtract to be -2. Okay, I know exactly what it is now because the amount of information I have matches what I don't know. So if you have to solve a murder, how many things are there that you normally don't know? A lot, right? Who was this guy? Who would want to kill him? Why would they want to kill him? Where was he? Where were you? Where were they? What time was it? How long has he been dead? Corner, do you know that? Holy shit and a half. There's X, Y, Z, W, L, M. And there's a ton of variables. So as you do an investigation, what are you trying to do? Get more and more and more information. Does that make sense? So we're actually kind of mathematizing this idea of there's a whole bunch of shit we don't know, so I need to know a bunch of shit, and maybe I can figure out some of these specific points that would help me show evidence that somebody did it. Okay, maybe. I love it. So, instead of, my God, can you imagine? The answer to some of these might not be that easy. The answer could have been 0.7 and 5.3. Would you have thought about that? Do I want to make a list of points every damn time and then just check? Hell no, there's got to be a better way. So we already know the answer to this. So whatever method I'm going to use to solve this, better frickin' come up with that answer, right? So do this for me. You could do this. Create a XY coordinate plane and graph both of those. So do number 1. Solve for y, slope y-intercept, graph it. Do number 2, solve for y, slope y-intercept, graph it. On the same plane, right? Each one at a time. Plot them on. Overlapping with each other. And let's see if we can see something nifty happen. One of you should work better. No. Yeah, dude. All right. Sweet. So if I work with the first one a little bit, I subtract x and I get this, right? Right? Okay, so that's a better form for that one. And if I work with the second one a little bit, let me see if some of you guys get this. If I add y and add 2, I get y equals x plus 2. There's no division by a negative.
Say that again.
See how the y is negative right now? So if I add y and add 2, I get y equals x plus 2. There's no division by a negative where I can make real easy mistakes. Do you have to do what I just said? No. But that's what I did. I just switched these. So y equals x plus 2. So that's what they become when you solve and put it mx plus b. So if you guys did subtract x and then divide by a negative, don't you get this? No? Are you guys all right? Right? If you subtract x, you get negative y equals negative x minus 2. When you divide by negative, everything becomes positive. You get this. Yeah. Okay. I like it.
Oh, okay, you just automatically.
So I just added y and added 2, so the y became positive. I don't have a negative to worry about. Always nice. Do you have to do that? No, you can do this shit. Okay. So how do I plot this first one? What do I know about the first one?
Negative 1.
What's the y-intercept? What's the y-intercept?
0, 6.
0, 6.
0, 6.
0, 6. I love it. Some of you guys have that exasperated. 0, 6. Jesus, just do it. All right. And then what's the slope?
This
Minus 1.
Yeah.
Minus 1 over 1. So I go down 1,
Right one.
over 1. Let's do it again. Down 1, over 1. Let's do it again. Down 1, over 1. Down 1, over. Okay, that's enough, Jeff. And there's the line, right? Weehaw. It's a little bit, pretend like it's straight. Let's have a rough day. Give it a break. Poor little thing. How do I graph the second dude? 0, 2. And you go up 1, bless you, over 1, up 1, over 1. Interesting. So remind me, let's see why this really makes sense. What point did we just go through? 2? 4, which is the answer, right? So when I graph a line, what's true about the points on that line? What do they do? When I graph one line, what is true about every point on that line? What must it do here?
Go down.
No, come on. Every point on this line, if I put it in here, it has to be true. It has to work. Right? If a line goes through a point, that point works in its equation. You guys with me? I mean, we talked about that already. So if a point works in the equation, it's on the line. If it's on the line, it works in the equation. Same thing with this dude. So every point this line goes through works in his equation. Everything this line goes through works in his equation. So of course, which point works in both?
Where they meet?
Yeah.
Where they intersect, where they meet. So that we have a graphical way to solve what's called systems of equations. Whenever I've got an equation that's got two unknowns, if they give me two equations, one way to try to solve it is graphically. I see where they meet. All right?
So what point do they meet at?
We know, we already kind of knew already, but what point is this? This is the point 2, 4. And isn't that exactly we identified earlier that we could tell was the answer? I like it. So just to remind those of you who are like, why did we do that shit when we already knew the answer? I don't always want to do this, right? I don't know. Oh, no. What if I just don't get lucky and don't list the right point? Well, with this method, it will always work. Well,
So basically just plot it and see where all the points are and whichever.
plot and see where they meet. See where they meet.
Plug it in.
That's the one place they're both true.
Okay,
I like it.
that's the next one.
So it's like, this is the equation that tells me where somebody was, and this is the equation that tells me where somebody else was, and that's where they both were at the same time. I'm like, you could have killed them then. Right? Or, really another place this kind of thing leads to is if I see a missile coming towards us, and I know its trajectory, which basically means I know the equation of where it's going to be. I'm going to shoot an interceptor missile that I've programmed so that the equation of him and the equation of him meet. Because then, of course, it blows it up. You guys see what I'm saying? So this is like the baby steps that lead up to that. Because that, of course, would be in 3 dimensions. But the basic idea doesn't change. An equation here, an equation there. I want them to meet so that this doesn't get to us and kill us. Right? That's almost too nice to believe. You can kind of see it happening. It's coming. It's coming. Oh, shit. Bam. All right, sweet. Yeah, we're safe. Here comes 5 more. Oh, shit. 5 more equations, bad boy. All right, so let's try another one. Actually, let me give you this. This might be easier for me and everybody. All right, let's see. I really want to know. You guys try. Is that the same problem? No. Thank God. It's almost the same. Try the first two. Right. Obviously, the side that says section 5.1. Try the first two problems. What's up? What about?
It says the pop-up theoretical student from the survey advice by an employer to support.
Uh-oh. That could be the beginning of the, we'll see.
What'd you just say?
Queen Mecca student, so you got that because you're a Queen Mecca student, so they.
No, Grossmont
for
sister
Grossmont
school,
and
so they, we.
All of our emails are.
Oh, good, okay. So you got something, so check your emails, apparently somebody at Queen
Yeah,
Mecca
might have.
self-quarantined?
Yes.
Their employer
But they were here on Monday.
Huh?
They were, the student was
And they're not gonna do
in
anything.
school on Monday.
Student was in school on Monday.
They think they might be positive for corona.
All right, we'll find out. I just wait for the Budweiser virus.
So if they come up with a decision for other math classes that they would allow them to do it the rest online, you'll send us an independent email stating that you won't? Or we should just know
It
that?
is going to, whatever the decision is, it's going to depend on certain students, right? There's going to be something that works for most students, and then something that doesn't work for every student. It's going to depend on instructors, because some instructors are completely, you've met these people, they have no idea about online. So there's no way they could possibly make it work for their students. So whatever the plan is, they're hoping that a majority can go online, but they're going to have something in place for those people that can't handle it, or people like me that are old school and don't want to let people take online final exams. Huh?
You should just pass people that already passed.
Would you,
8 weeks.
could you teach online lectures like you
Yeah,
have been?
I was telling my colleagues, it's easy for me. I would just send out a link for the lectures that correspond to what I would have talked about.
Don't you have to meet somewhere?
They're not perfect. They're not the same as being in class, but there's something. That's the thing that needs to be worked out. If Grossmont shuts down, would they still be okay with some students coming, like twice to do a test and then a final? We don't know. That's part of what's being discussed. Yeah, exactly.
Okay, so do you,
Like
yours
the
like cheating on tests? Is that why your kids online? You don't want to cheat like on tests?
There's no way for me to guarantee. That's why if I taught an online course, I would do proctored tests, where you have to go somewhere and show an ID. Right? If I taught an online course. So this makes it go even further than that, which I would never do on an online course. And I'm not. I know some people would do it, and it would be them. But there's no way for me to know who. And then what I'm doing is I'm setting you guys up for failure
Later on in other classes, you would have to.
if they didn't really get it really, and then they need it for later.
You're just not passing out grades either, we gotta make sure we understand it.
That's right. Yes.
I do have a question.
Oh, what's up? Solve for y. See, this is already solved for y. But see, if you add the y, you have to subtract the 2. So if you're not sure about the shortcut, wait a minute. The 2 was, see, the 2 moved. How did it move? Do you see what happened? Was the 2 with the x before? No. But now it is. How did that happen? It can't just get up and move. You have to actually do something. So then don't try the shortcut. Yeah, you don't have to do a shortcut.
Okay. So, on the one that we just did, didn't we just do one?
I don't.
Oh, here, okay, so, what happens is, you know, how you get a negative y.
Yep.
So you
So
divide
you
it
divide by
by
-1 and then
I
put
think,
it as positive. Yep.
but I thought you got a negative 1 or positive for this one, right? Negative 1 over -1, and one of the positive.
Negative and negative is positive. That's why it was positive.
So my
that's
question
two.
for this one, is it negative 1 to negative 1? Is it divided by?
This becomes positive.
Yeah, okay.
Yeah.
So it's just one of them.
Yep.
Okay.
Oh yeah, that's why it's said just do the first two. But what do you think, if the answer is where they meet, do these two ever meet? So then what would the answer be? No solution. Yeah, does that make sense? If the answer is where they meet and they never meet, there's no answer.
Negative x minus 2.
What's happening? So, if you subtract, why are you subtracting? Oh, I see. But it, all right. So don't use the shortcut. So, yeah, just solve for y like the order. Right. So subtract x, divide by -1. Right. The way you always would solve for y.
Okay.
Yeah. Yeah, y equals 6, I like it. And then you can check this, right? So there's an issue. You've got it turned the wrong way around, you see that? Because if I go to check this, isn't this for x and y? With that would be 2 minus 4. So see, it's 4 to. Yeah. So you can always check it, plug it back into the equation, make sure it makes it work. I don't know if you guys picked up on what I did up here when I did extra steps. If you do extra steps, then you can really see where they meet. If you're just trusting yourself to draw a straight line, maybe don't do that. Especially if you're me. So that's why I did extra steps, so I could really tell where they met. All right, let's try that first one. The first one's a lot like the one we just did. This is the same as what we did earlier. Subtract x, bam. Doing this the non-shortcut way would look like this. Is that cool? The shortcut way, let me see if anybody sees. See, if I add y, I subtract 2, so that would die on that side. Y and -2. If you don't quite see that, never do it. It's not necessary. It's a very tiny shortcut. Doesn't matter. So here's one equation, and here's the other equation. So if I plot both of those, I should be able to see where they meet. Bump, 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 bump. That's roughly a good scale. So let's see. This guy's like what we did earlier. It's got a 6, and then I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. All right, that's plenty. Weehaw. Oh, crap and a half. There's a crap and 3/4. I don't know. 2, 3, 4. Okay. And then x minus 2. So 0, -2, and then up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. There we go. So what point did I end up going through?
4-2.
4-2. And then if you check it, sure enough, 4 minus 2 is 2, check. And 4 plus 2 is 6, check. I like it. What about the next one? Just cutting to the chase, you should get these two equations. Let me make sure I looked at that right. Yeah. That equation and, yeah, this is not too bad, right? Is that cool? Mm-hmm. So go ahead, if you haven't graphed those yet, graph them. See if you can see what the answer is. Just in case you know the algebraic ways to do these, I don't care yet. Don't do them if I ask you to graph it. We are going to learn algebraic ways, because what if the answer was 1.09 comma negative 0.11113? I am not going to get that from my crappy ass graphs. I could barely get the freaking whole number answers with my horrible scale, right? So there has to be an algebraic way to answer this.
That's in the structure too.
That would be 5.2 and 5.3 are the two algebraic ways to do these. This is all 5.1 up here. So if I go to graph these, I think I told you guys, if you're going by ones, you don't have to necessarily label them. Anything else, you must label it so I know what the hell your scale is that you're using. And I think I said this before. Have I said this? If you're using lined paper, use the lines as your tick marks, right? Some of you guys are just like, you have lines, right? Use them. Or get graph paper, even better. All right, if I was in my class, I would make me get graph paper. Holy shit, right? I need some help. Okay, all right. So what do I know from this first line?
You start at 0, -4.
Yeah, 0, -4. And then I go
Up 2 over 1.
up 2 over 1. Up 2. Let me do it a few times. Up 2 over 1. Up 2 over 1. All right, let's see. Hopefully that's enough. If it's not, I'll just do some more. The second line,
Oh, so maybe that.
what do I know about the second line?
Start at 0, 2.
0, 2. And then I go down
4.
4 over 1. So 1, 2, 3, 4 over 1. Yay! So what's the answer?
1, -2.
1, -2. Kick ass. And how do you check that?
Plug back in.
You plug it back in. So when x is 1, 2 minus 4 is -2, check. When x is 1, -4 times 1 is -4 plus 2 is -2, check. Yay! This is where they both agree. I like it. Some of you guys have tried number 3. Go ahead and try number 3. Just to warn you ahead of time, it's a little bit weird.
I just wanted to check where I messed up on. I decided working with them.
Yeah, let's see what happened here. So you subtracted 2x. So why is it positive 2x there? So why is it 4 negative? What happened? So watch here. Look, Curtis. You put in -2x, put it over here too. -2x. So what's that? 2x is negative, right?
Yes.
4 is positive. What happened there? 2x is supposed to be negative, 4 is supposed to be positive, right? Do you see that? For some reason 2x became positive. Isn't it -2x and isn't 4 plus 4? So you kind of like change everybody's sign one step too early.
Yeah, I think that's what I'm making.
They were Virgo. You made it.
I started trying to divide.
Huh?
I was thinking of division while I was trying to add, but it confused me.
All right, as long as you weren't thinking when you churn them around, the sign didn't go with them. So if the 2x is negative, it's going to be -2x wherever it is.
Okay.
Yeah.
Do these not meet their
What's up?
parallel?
Ah. Hopefully, maybe somebody noticed something weird from the beginning. If I said, I don't know why I'm picking on you and me, if you add our ages together, you get 60. And then I said, if you add our ages together, you get 40. What do you say to that? Well, if you add our ages together, you get 60. And if you add our ages together, you get 40. What do you think about that? Come on, give me your immediate reaction. Come on. What are you going to say?
That's bullshit.
Yes, there. Who said that? That's bullshit. That's perfect. That's bullshit. Right? So look, this number and that number add to be -1. Oh, but they also add to be 2. What numbers do that shit? If I take a number 2x and add it to y and I get -1, how the hell can it also add up to be 2? Do you guys see that? Do you have to see that at the beginning to know something's weird? No. So let's pretend like we didn't see that. So if I do number 1 and solve for y, subtract 2x. And number 2, I get subtract 2x. So when I go to graph this, what's the y-intercept for the first one?
Negative.
Yeah, so -1. There it is, Jeff. And then I would go
Down 2 over
down
1.
2 over 1. Gee-haw. This guy's got a y-intercept of
2.
0, 2. Then I would go down 2 over 1. Yee-haw. And already we know, of course we know right now that these two are parallel because they have the same slope. So if the answer is where the lines meet and the lines never meet, what's the answer? No solution. No solution. Bam.
So this is showing us what a parallel line is.
So it's putting a few things together. The fact that equations can have no solution. We've seen that already. So just because these go to higher level dimensions, they could still have no solution. Right? And also reminding you what parallel means and then showing you that it means a little bit extra now. If they're parallel, there's no answer. Like it. Okay. There's nothing neat about 4. Let's do one more neat one and then we'll call it a day. How about all right, graph those two. Tell me what the answer is. Oh yeah. Somehow I made it through today.
It's the same.
So I'm sure you might be noticing that when you divide this by 2, you get the same thing, right? So if you plot this one up to over 1, is that cool?
Mm-hmm.
And then if I plot this one up to over 1, now let's see if you guys get this. The answer is where the two lines meet. So how many answers are there? I like that's interesting. Infinite number of answers. In fact, specifically the answers are where do they meet? They meet at every point that is
On the line.
on the line. So the answer to this would be all the points on this. It's the same situation we're in. So this is what I meant by two different pieces of information. So going back to us, if I said she's half as old as I am, and then I said, oh yeah, I'm twice as old as she is. Did I just give you another piece of information? She's half as old as me. Oh, and I'm twice as old as she is. Did I just give you two distinct pieces of information? Think about it. If I say she's half as old as I am, don't you already know I'm twice as old as she is? Did I just tell you something new? No. So if I am twice as old as her and she is half as old as me, aren't these both the same equation? So I didn't really get more information. So of course I'm not going to still be able to solve it because I haven't gotten a second piece of information yet. So this is like, let me tell you this. Oh, and then let me tell you this. I'm like, you already told me that shit. I still don't know shit. It could still be any point on that line. Does that make sense?
Yeah.
So it could either be one answer, no answers, or infinite number of answers. So when will it definitely be one answer if they are not with the same slope? Right? If they're the same slope, different y-intercepts, no answer. Same slope and same y-intercepts, infinite number of answers. All right, maybe. Freakadelic. All right, yes.
The stuff in the back we're not going to do on the homework tonight.
I mean, you can if you want to. You can always get ahead. But we're not going to talk about 5.2 yet. So 5.2 is the first algebraic method to doing this. So we can get answers that are freakier that I don't want to deal with on a graph. Okay, so you can do through 5.1. That's my fifth puberty. And you probably want to soon because that quiz on Tuesday will go through 5.1. Otherwise, that's plenty. And just, you know, keep your eyes out for any new information.
So if school does get canceled, we have to redo all the work that we've done?
We don't know.
Okay.
We do not know. What will be the most equitable thing to do, we don't know.
So keep doing work.
Just keep doing work. Yeah. Oh, on the sheet we're just doing?
I don't know that. I wrote infinity, and he did that one. I'm like, no, it's not.
So I can tell. Oh, thank you. I can tell that they're gonna be